So Chris, right now we're doing our first stage, which is our terpene strip. We have our evaporator, which is the upper body right here, set at about 145. Our condenser set at 30, which is inside this area here. And our residue, what was generally the waste stream, but this is our feed for the next stage over here. This area is set at 120. The reason that you have these differences in temperatures between all these areas is because you want your evaporator doing what it says it is, and then evaporate. It evaporates our lighter molecules right now, which is our terpenes, solvents, other molecules that are within that range. And those are lighter molecules, a little bit different configuration than what CBD and THC and our other heavy molecules that are coming through on our residue side are.
So what's the temperature of this line right here feeding into the terpene strip line?
So this is what our condenser is right here. So our condenser goes all the way from this about right here, all the way down through into here.
Okay.
And if you look on what's coming out, you can see just a tiny little drip right now. And that drip is all of the stuff that is evaporated off of here, come across and condensed on the condenser itself.
Okay.
This is our target analyte on this system is our residue line, and that's all of our CBD and THC.
So these molecules over here were freed from the oil phase.
Correct.
And now all of these are untouched.
Correct.
Well, not untouched, but they couldn't break free of their liquid state.
Exactly.
So if so this is about, you said 30 degrees, right? The condenser in here? 30 degrees throughout, all the way to where it's dripping down here?
Correct.
So then what's the temperature inside
Actually,
of here?
through this whole section, all the way through this whole section.
Okay.
Everything's at 30 degrees. So there's no change all the way down through there.
Okay, so then it just builds up and that creates a flow down all the way to the line. Okay.
Everything condenses on to that centerpiece condenser and runs down into what you see dripping right there.
So then what would happen if we took this condenser and, if we're catching terpenes, we can clean those up and sell those. So what's stopping us from collecting everything that we can? Why don't we set that to negative 20 or 0 degrees to be more efficient?
Well, what we're using to separate these molecules is the principles of thermodynamics, right? So mostly we're looking at boiling pressure or boiling temperature and vapor pressure and how those relate to the molecules that we're looking at. On the other side, to get those off, I should say, we're using boiling points and vapor pressures to get them off and separated from each other. When we're condensing them, we want to use the opposite.
Right.
We want to use their dew point, which is going to bring them back into solution so that we can bring them out. When we talk about boiling point, there's a couple things that change what something has for its boiling point from low to high. If it's a larger molecule, it's going to have a higher boiling point than a lower molecule. So that's why the terpenes come off at this temperature. And we also use vacuum in this case to change that a little bit. But those lower boiling point molecules, terpenes, come off at that lower temperature and condense. Their dew point is at that specific range of 30 to 50 degrees right there at this atmospheric temperature.
So it's a specifically selected temperature to try to capture a section of what you're actually pulling off, because we still have some stuff coming in through the cold trap, but not everything is desirable. And
right. And oftentimes our cold trap here, so this is our condenser, residue, evaporator, condenser, residue, distillate. The cold trap here is protecting all of our instrumentation on the back side of this here. And this collects all the extra things that just have too much energy, too high a boiling point, and we're missing their dew point, their condensing point here.
Right.
That protects everything and comes out over here. Should be a very small amount, generally, is if you have the correct setup through your system here. let's go ahead and take a sample.
Okay.
So one of the things that we're gonna do is we're gonna look for cannabinoids in this sample. Let's take a sample of the heads, the lights coming off of this, and see what we come up
So
with.
the greater the difference between your evaporator temperature and your condenser temperature, the more pool there's going to be for molecules to switch
Phases.
switch phases and condense. So if we had that condenser running at 10 degrees instead of 30 degrees, and we had everything else at the same temperature, that's going to create more of a force that will pull things like CBD into the distillate stream.
It's very possible because what we're looking at here at this atmospheric pressure or this vacuum pressure is we're actually looking at a mass transfer. When we're in this type of area over here where we have a much lower vacuum, we're looking at molecular diffusion.
Oh, okay.
So here we can create what you're saying is that large temperature gradient and a lot of force going from this evaporator into the condenser.
Right.
And it may, as you said, bring more into that, more molecules into it, not the ones that we're looking for though.
So it's not all about boiling points and specific numbers. It's about the conditions and gradient of the system that's going to create like basically probabilities for molecules to end up in certain streams.
Perfectly put.
Okay.
One of the things I'm looking at right now is your streams that are coming through here. Here we have a really good residue stream where most of our product is coming down this side.
Right.
We know that this is a very low terpene content crude that we started with. But what you look at here, see the viscosity of the drip coming off of there is much less than what it is here. So this drip may not be indicative of what's coming out there.
Different pressures.
Different pressures, a little bit of a different temperature, but I think this is a little bit older when this system wasn't running perfectly yet.
Right.
So I think we can do it now.
So what would you do differently with crude oil that has, let's say, 15% terpene content versus one that has 1% terpene content?
One of the things you could do with the higher terpene content, you could slow your feed down so it has longer residence time and allows the product to be in contact with the evaporator longer, allowing more transfer of energy and boiling off of more of those terpenes.
Okay. All right. Here we go. So I'm going to fill this first distillate sample. I'm going to try to get it to about a quarter of the way up on this 20 ml vial. Maybe a bit less though, it's dripping pretty slow here. Couple more drops here and I'll be ready to weigh. Okay. All right, placing it back on the scale, which was used to tare it. All right, and we took 1.532 grams from the distillation system. And this is stage 1 distillate sample number 1. Go ahead and cap this while I get set up. All right, we have our D1 vial, the final sample vial, and I will grab our internal standard, which is in the freezer. Okay, so I have our IS fresh out of the freezer, and this is a head sample. I can go ahead and prep the syringe as well, so we have everything ready for us. Head samples will require a nylon filter along with a quick catcher. Just place this back in here, have that set up. And the reason I reconnected my plunger is just to try to avoid any possible contamination, as well as these open vials here. It's good practice to go ahead and attach their caps so that they're not just open to the air. All right, so our first step in the process is going to be weighing out our sample into our D1 vial. So I'm going to go ahead and tear that vial. Try to place it right in the middle. If it's not perfect, it's fine. But you do want to stay somewhat consistent between your tear and your actual mass measurement. All right, for head samples, I prefer to weigh with the little droppers here. Makes it a little bit easier once you get the hang of it. It's pretty easy to hit your mark every time. So for head samples, we are shooting for 50 milligrams or 0.050 grams. Okay, you want to avoid touching for sure. There you go. I usually get my first drop there to kind of gauge how dense the material is. So this stuff looks pretty heavy, so I'm going to do one more drop and see where I'm at. 43. This will put us in range. We want to try to get our sample weighed out in between 0.040 and 0.060. So there's a plus or minus 10 milligrams there. I'll go ahead and do a tiny drop if I can to try and match the weight perfectly. Okay, just touching it to the side of the glass there. And that looks good. So anytime you're happy with your weight and you're ready to cap your vial, you want to make note of the amount of material that you just added. So for me, I prefer to write it on a cap. So this is stage 1, distillate 1, our vial D number 1, and we have 0.053 grams. Okay. Just gonna do a quick purge of this line. This pump doesn't have a purge feature. All right. Okay. Now ready to add our solvent. For our first dilution, this is going to be a 10 milliliter dilution. The pump is set here to 10 milliliters, so I'm just going to pull up all the way, pump down, avoid missing any drops here. So we've altered the scale of this sample preparation so that any tiny mistake isn't going to ruin your ending results. There is a little bit of room for extra drops or missed drops, so there's no need to throw away your sample if you don't make a perfect transfer with, let's say, your methanol. But definitely keep an eye on it and try to stay as precise as you can. All right, so these head samples go into solution very easily. I just do a little visual check here to make sure I don't have anything floating. Looks fine to me. So now we have our vial D1 in solution. We're going to take our D2, which is our internal standard, and we are ready to make our second transfer. So for this part, I will dip the tip right barely under the solution line in there. And then I'm taking it over to my D2 vial. Same thing, tip just into solution and going to depress to push the solution out and up to pull more solvent into the tip. And I want to do that 3 times to rinse. You want to make sure that you get all of your D1 solution into D2. That's the reason that we rinse here, because a transfer that's not as precise for this step will be more likely to hurt your results. This is the most important transfer most important step in the procedure. So take your time, be careful, and make sure that all 10 microliters make it into your D2 vial. I like to do a quick shake just in case any solution happened to get on the cap or anything inside of the vial. So that's fine. Now we're ready for our filter. So pull this cap off and have everything ready as soon as you get your solution into the syringe. So it's going to take a couple taps. The solvent that's used in this vial creates sort of a bridge, a tension bridge in the vial. You have to tap it a couple times to get everything out. All right, you want to line up the spout of the quick catcher perfectly in the center of this vial so that it's not touching any of the glass, and it just drips perfectly down into the bottom. Okay, and that's it. We have our final sample. Just for logging purposes, I'll write down the sample. Stage 1, distillate 1, final sample, and that original weight that we took was 0.053 grams. Okay, sort of legible. Parameters.
You want me to read them too?
Yeah, that'd be easier. Feed rate,
Feed rate is 15.
15. Wiper speed.
Wiper speed is 200.
Okay. Evaporator is 145.
145 for this sample.
All right. Condenser is 30.
Correct.
Residue
120.
120. All right. Cold trap negative.
Negative 24.6.
All right, and then vacuum pressure.
Vacuum is 0.76 torr.
Okay. Put in the weight here, 0.053 grams. All ready for a swab. Okay, that first sample was at 19%.
So what that tells us is that we have cannabinoids coming through on this into our condenser and coming out this distillate stream. So one of the things that I want to look at now is how can I lower the amount of cannabinoids coming across this side over here. The first thing I would look at doing is changing the evaporator temperature. So I change the evaporator temperature down about 5 degrees, and we're going to allow the system to equilibrate. We'll take another sample, See if I lowered the cannabinoids coming through or raised them with that change.
60. Just one more time. 59. Okay, we'll go with 6. Oh. These balances can hear you, so. Okay, 59. So our D1 is going to be 0.059 grams. Okay, take it over here. 10 milliliters of methanol goes in. Nice little 20 to 30 second vortex. Again, head samples go into solution very easily, so don't need too much agitation. Alright, looks good to me. And grab a internal standard. Okay. To microliter. Transfer of D1 solution into our D2. Rinsing 2, 3, 4. I'm depressing the pipette, and I'm sort of bending the tip along the side of the walls, just to kind of get any little droplets that may get caught up at the end of the tip. Again, this is the most important transfer in the procedure, so you want to make sure to get all of your cannabinoids. Okay, head sample. And to load it up with both filters. Five microliters for the drop onto the swab. Into a hot plate, and we can go ahead and enter our information for this next sample. Okay. What parameters did we change?
We changed the evaporator down to 140.
Okay. And why did we go lower on the evaporator?
Trying to reduce the amount of energy put into the system.
Okay.
So hopefully reducing the amount of cannabinoids being pushed into the distillate stream or our lights.
And the only way we can really do that is by not allowing the CBD to leave the oil state.
Correct.
You can't do anything with the condenser, because if you adjust the condenser to, quote, ignore the CBD, then it's definitely not going to be capturing any terpenes.
Right.
So with the cold condenser, all you're left with is the evaporator, right?
We also have another option, which is the residence time. So I can speed up the speed.
Okay.
Will also make a difference.
What do you think is the difference between adjusting one over the other?
Oftentimes people are looking at their run times in just strictly time. How long does it take me to do something? And so they oftentimes will just run as fast as they absolutely can. So generally, if you use your evaporator temperature first, that's an easy way to go about it without adjusting your feed rate at all.
I see.
Keeping a high feed rate if you need it.
But I guess it kind of comes with like maybe the quantity, like you were saying, of terpenes. If you need more terpenes, you don't want to necessarily do it through your evaporation temperature because that's going to hurt the chances of CBD making it through to the other stage. Instead,
Right.
you just want to increase the overall time
Right.
so that they all get a chance to get exposed to it. Okay, 18%.
So we're dropping it down.
Yeah, we're dropping down, and I can tell from the viscosity of it.
So I already made the temperature or the change in our feed right now.
Mhm.
So I don't want to go much lower in evaporator temperature because I want it to
You want to see?
make sure that we get all the terpenes off.
Okay.
So we'll take another sample with the lower feed rate. It's that.
Okay. 16. Trending down.
Trimming down. So all these work and we can just continue to adjust what we're doing here.
Mm-hmm.
And really what we want to have is probably down from about 5 to 10% cannabinoids in this strain.
Okay.
We'll continue to make adjustments and we'll get down to that 5 to 10%.
So let's say that we have a material that has, kind of like has a terpene profile with more heavy terpenes with higher boiling points. Is there, basically what I'm trying to say, is there a lowest value for the head sample as far as cannabinoid potency depending on its composition? Like is it harder for certain materials?
Not necessarily. You can go all the way down to having 0 cannabinoids in your terpene side.
Mm-hmm.
But that brings us to the next portion of it, is our second stage that we're looking at. So as you go through this stage here, we want to make sure that we retain as many cannabinoids as we can in this retinate stream that comes in as our feed for our second stage. We want to get down to that range of 5 to 10% terpenes over here, because we want to make sure that we get everything off in that whole range that you're talking about, some of the heavier ones.
Mm-hmm.
We want to make sure that those come off, because in this stage, our second stage, same as our first, we have the evaporator, condenser in the center, residue on this side. This is our distillate on this side, cold trap, and a vacuum system here. We have 2 vacuum systems on this side. We have a scroll pump, and we also have a turbo pump here, bringing our vacuum down to 3 to the -2 torr is what we're looking at here. That changes what this is, essentially, to a molecular distillation system. Now, when we have this good low vacuum, we can have temperatures that are much higher and much different that will not only protect the target analytes, our cannabinoids and our THCs, we can protect them at these vacuums and separate as much off as that we possibly can. So what we're looking to do here is we're going to get this stream, our residue stream, to be under 20% cannabinoids in here. And this side over here, we're going to get our cannabinoids up. For CBD, it's generally 80 to 90. THC, it's above 90.
Okay.
One of the
And
things,
if you had a bad stage 1 strip, that's going to show up poorly in your potency.
it's going to show up over here because we don't have as good a vacuum. One of the key features to this type of distillation is how good your vacuum is and how well you control your vacuum.
Okay.
So let's go ahead and take a sample here.
All right. We're getting ready to take our first tail sample, the stage 2 residue. All right. So we're going to set up our sample vials over here. This is the vial that we're going to collect in. All right. Now, tail samples, you have to be a bit careful. This can get very messy. It's very, as you see there, stringy. Very heavy as well, so don't need to collect too much. About a quarter of a way, just like with the heads. Oh my goodness, I'm just everywhere. All right, that's okay. And again, it's not super important to know the exact weight for this step, as we're not doing anything directly with this material. We're going to be doing a transfer to our D1 vial, but let me go ahead and try to get this cleaned up a bit. Okay, material on your neck or on the outside of the glass. It's not desirable, it's messy, but for this weight collection vial that just contains a sample, again, it's not a big deal if we don't know the exact weight in here, but for our D1 vial, in which we transfer the material into, this does need to be neat and, it needs to all make it down into the vial. You don't want it on the outside or on the neck, because that gives you mass that will be included in the calculation that does not actually take part in the ionization. So now for tails, we're looking to scoop 0.020 grams. And for tails material, I use these micro spatulas. It's the most precise technique that I've found. It's very stringy. You could pull it out and it'll just pull all day. Kind of roll it onto the spatula here, and it will break the strand. So now just come in there, avoid the neck, and kind of smear it along the sides of the wall. And let's check the weight to make sure that we're not overweighing already. Okay, not bad. So I'm happy with this weight. I'll go ahead and...
So what are the major differences between the heads samples and the tail samples?
Really, the two main differences are the target weight that we're scooping. Mm-hmm. For head samples, we want to get 50 milligrams. For tail samples, we want to get about 20 milligrams. Then the other main difference is the filtration. For head samples, I like to think of it as you need to put the... I should probably swap my gloves out here. The way I remember this is you have to put the head on to the head samples, so it needs the nylon filter, and then you attach its head here, which is a quick catcher. Tail samples, it's just going to be our nylon filter only, and just make sure it's not contaminated. Okay, so let's go ahead and record this weight. This is our D1 vial for tails, and we have 0.028 grams. And this is our first tail sample. Okay. Same volume for all sample types. It's always going to be 10 milliliters. That's never going to change. All right.
So sample prep is very similar.
Very similar
in both cases.
And then another difference that you'll see is that stage 2 residue, it takes a lot more agitation to go into solution. It likes to stick onto the side of the glass. So, I would start by shaking it for about 30 seconds or so, but you're really going to need to stop and visualize inspect the vial to make sure that you don't have any big chunks that have not gone into solution. Because again, any material that is included in the mass that's not involved in the actual, analysis, it's going to hurt your result.
Changes what our potency would be at the end, right? So you want to make sure that everything is dissolved in solution.
So we're going to tell it what our concentration is, and if not all our material is in solution, that's not really the concentration. So it's going to throw off our potency calculation. And this looks much better. There we go. Everything looks like it went in solution. And obviously you can tell stage 2 residue. It really gets cloudy, and you can definitely see that you have sample in there. Heads material, a lot of time it'll look like a semi-clear solvent. All right, let me see what I'm doing here. Internal standard, right out of the freezer, and we're ready. So since the solution's been sitting for about a minute or two, I'm going to go ahead and vortex again. There's a lot of stuff in this Telmus material that doesn't like to really go into solution, so you don't want it sitting around too much before you make your transfers. Okay, we have our D1, we have our D2. Same thing that we did with the head samples. We're going to take our 10 microliter pipette, tip right into the solution, not too far in. Same thing on the other side, dip it right into the solution, rinse, 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 down into the solution, pressing all the way and bringing it up against the glass. You can see a tiny, tiny bit still in there. I can kind of pump it out. Let's see. Yeah, it looks good. Okay, we're ready for the final transfer into our last vial. So it's going to be, we already have a syringe. So again, tail samples, nylon filter only. And side note for this part, this transfer, obviously is important as you're filtering your final solution. But if you don't make a complete transfer or you lose a little bit, it's fine. As long as you get enough to make your drop onto your swab and you have a sample that represents what you collected, it's fine. 5 microliter. Drop into the swab. Place it onto our 100 degrees hot plate. Okay, so now since it's tails, we're going to select the tail sample type. Our parameters.
I'm going to tell them to you.
Yeah, I need to get used to where these are. I forgot. Okay. Well, where's the feed? Okay. 15.
Yep.
So feed's at 15. Is wiper speed at 200?
400.
400, okay. And that's because of the viscosity.
Your evaporator is at 175.
175.
Residue is 140. Condenser is at 90.
90. And then vacuum?
The vacuum right now is 0.03 torr.
So Joe, if we stripped off our terpenes and we see some cannabinoids still in there, so that tells us that we're probably cutting deep enough to collect all of our terpenes. So we already stripped those out. Why are we still running the condenser at 90 degrees? Why don't we just go with like 30 degrees so that we can, be more efficient with collecting the CBD?
Cannabinoids don't like to necessarily condense at 30 degrees. So
23 in our tails.
well, that's good.
Pretty good start.
That's a good start. So when you're looking at why do we have our temperature of our condenser at that specific temperature, right? Just as boiling point is affected by molecule size, molecule shape, the types of bonding in it, if it's covalent, ionic, hydrogen bonding, all those things make a difference on the boiling point. Everything on the back end of that, when it's on its condensation point or its dew point, makes a difference as well. One of the things that we're looking at when we have this system set up at this type of vacuum, we are looking at molecular distillation. So the difference from this level here, this stage here, compared to our first stage when we're doing our terpene strip, we're using temperature as our gradient to show where the molecules can go to. This one, we're looking more in the realm of concentration. So when you're looking at any type of reaction, the driving force in reaction, it goes from high concentration down to low concentration, right? That's the transfer of energy for that. That's what's going on here. So we have high concentration. It wants to come off because we're giving it enough energy to vaporize that molecule, leave everything else behind. When we bring everything else behind, all our fats and lipids and chlorophylls, all that stuff, very heavy molecules come off on this side over here, not necessarily fats, come off over on this side, and that's our waste stream. We're trying to get as little amount of cannabinoids in there as we can. When we burn those off, when we vaporize them, they're wanting to condense somewhere else. So with that high concentration here going to a low concentration here, we're giving it that direction, that force to go into that area. Then we take that temperature that it's condensing onto, which is similar to what cannabinoids like to condense to. Generally, it's a range of 80 to 120, somewhere in there. And we find the best temperature for what we're working with on this particular starting material. So now we have our residue feed. There's 23% cannabinoids in there. And our distillate side over here is the remainder. One of the things that we're looking to do too is with our condenser temperature, we want to look at how good the color is coming out. So it's a metric that we use in the industry to look at how good the quality is of what color we have.
So if we were going too cold on the condenser and CBD was condensing on there, but it wasn't really able to flow down as well, would you expect a darker color? Does that temperature of the condenser always also play a role with like viscosity in mind, so it can flow nice?
Viscosity is important there. Also, what else are you condensing? If you're going to a lower temperature, you can condense other types of molecules.
Yeah, I mean, you're gonna still have you're still gonna have some isomers, some terpenes that didn't get taken out. Maybe even, who knows, some water, depending on if your vacuum's holding up all right.
And that's one of the things that we get on this side back over here too. So all that extra volatiles that are coming off, we're saving our vacuum pumps with our cold trap, and that's why you see all this extra stuff coming off over here. So that's some of that there. Or it's coming over in here if we condense it down, if we're at the wrong, I shouldn't say wrong temperature, but not the optimal temperature here. We're gonna have more color come into this section here and change the color of our distillate.
So we have our evaporator. You can think of that as like, it's picking which molecules it wants to let free and give a chance to get collected as a distillate. It's selecting it through the energy that it's giving to it. Right. So it's not really picking, because you can't just select one or the other, but it's
the ones that evaporate at this temperature, we're choosing those, right?
Right. So if it evaporates at this temperature, you're selecting that one, but you're also selecting everything under that. The way to selectively choose which molecule you want to collect is, okay, you've freed all of your molecules, now you have to select a condensation temperature, the
Right.
condenser, that will collect what you want while, let's see, so all things that are very heavy will condense onto it. So it's got to be hot enough to let lighter components pass by it, and then it's got to be cold enough to allow your molecule to catch onto it.
Right.
But if you freed up too many things that are heavier than your molecule, in our case, if you freed up tails components and we want CBD free, no matter what, it's gonna condense with CBD. You can't do anything about
Correct.
it. So you have to avoid letting the tails material free.
One of the things that we can use too in this situation is that the residue is a very important area to look at, and what your temperature of your residue zone changes what you can bring into the side or recondense into this area. So if your residue is the same as your condenser, you're only gonna get a 50-50 split, and you're gonna condense cannabinoids in here and here because they're the same temperature. If your residue is at a lower temperature than your evaporator, which is generally what you want it to be,
Right.
you are going to condense some of the things that don't necessarily like to condense on the condenser temperature here, and you can bring some of those heavy molecules back through your residue side. Even though you did evaporate them here, you can condense them here too. The
Would
other
you-
thing that we have an option to do in this situation is we can take and raise our feed rate. So
yeah.
residence time is, I'm going to guess that it's probably one of the most important things that we're going to be able to look at. And that residence time is going to tell us more about this whole process than anything. So we should,
I would go for that.
I like our system. I like the way it's set up right now. We're looking at 23% generally for head or for tails on a two-stage system like this. I want it to be under 20. So we're right there. Anything under 20%, you often have difficulty keeping your pumps running because it gets so gummed up and
Yeah.
so difficult to work with. So let's up our feed.
Okay.
Um,
Up our feed, so that will give. So the material is going to be exposed for a less amount of time, which I feel like it's hot enough to where it's not gonna it's not going to hurt the condensation of CBD.
right.
So we're doing this to protect the potency of our distillate.
Correct.
Okay.
So, and you can take a look at this here. So take a look at this. Great. We have really good color
Really good color.
distillate, which means we're not condensing any other analytes that we don't want in the system. We should have really high CBD in here. I would say 88 to 90 right there. And our streams are, you can see the feed of each stream right now. They're fairly similar, but our distillate's a little bit faster, a little bit quicker stream. So we're pulling more to this side, which also increases our mass yield. So we're bringing more cannabinoids in. We're increasing our mass yield, our potency, and changing and keeping a really good quality color.
So this is kind of like just a side question. If you did, so if we poured it in our crude, we ran the first stage with these parameters, and we collected our head and our distillate in this jar, would it be a very sloppy separation between the tails and the rest of the material? Because if you did this cut first and then came over here, and then you did your terpene strip, like I wonder if that would help a lot with the color.
So you're saying do the polish before you do the terpene strip?
Yeah, under that vacuum though, you're not like. I guess you'd have to catch your terpenes with cold trap mostly.
Right. So people who do a strip in that way,
Yeah.
to do a single stage, in the way that it's done here, you have such a better vacuum. So we're down in 0.004 right now, Tor, which is a really good vacuum. That creates a better product.
Yeah.
So anytime that you can remove all your terpenes and and change all of that, because anything left over, any of those high volatile analytes cause problems for your vacuum.
Mhm.
If you can get rid of all that stuff
Okay.
and have really heavy molecules and then your CVD left over, you can get a good separation here and good yields on your product.
I see. Okay, that makes sense.
That was a good question.
Yeah,
Good setup.
it's like
That was a good setup.
that. Yeah, that makes okay. So we're that's why the heavy is always second, because we got to take it to deep vacuum, but to do that we have to remove everything that's going to cause it to go crazy.
Right.
Just like with the Summit, you have to work your way up to it.
Yeah, you have to work your way up to it, right? And so people are doing that. They're they're running this really super hot and throwing everything into there
Yeah.
and trying to do a one-stage system that will
Ex-
get
yeah.
and you can do it, and trying to do this in a what is called a your heads, mids, and light or heavies. So you have
Yeah.
your lights, mids, heavies. That's what that system would be. It's not ideal because we have such a intricate system that we're working with.
Yeah, if you're pulling out your heads whenever you're trying to make this cut, you're like your atmospheric equivalent temperature is just going to be like
Jumps all over
that.
the place.
there's
As
a
well
very
as
fine line.
that type of distillation is more for the oil and gas industry, and
Okay.
that's all at atmosphere.
Yeah,
anyway.
yeah.
So it's a very different setup.